is your video lesson for solving exponential equations. This is something that does go along with exponentials that you may not have seen before, so I wanted to make sure that I covered this because this is a very useful skill to have. It does tie in our rules of exponents as far as powers to powers and quotient of powers and product of powers and all those types of things. So everything that we're going to do today, you can solve without using a logarithm. As we move further through chapter 6, our exponential and log chapter, we will get to some equations that look like this that you won't be able to solve by rearranging your base like we're going to be doing today. But everything you can solve without a calculator here. So part A, we're given the equation 3 to the x equals 9 to the 4th. The basic idea behind all of these exponential equations is that you need to write them with common bases, and then you can essentially disregard the base and set the exponent of one side equal to the exponent of the other side. So for part A, I have a base of 3 and a base of 9. Well, it's possible to write the 9 as a base of 3. So that's what I'm going to do. So I have 3 to the x equals 9 is 3 squared, and then that's to the 4th power. Now, with the 3 squared being to the 4th power, when you have powers to powers, you are able to multiply exponents. So 3 squared to the 4th is going to be 3 to the 8th power. When we get to this point where you have a base equal to a base, you can cross out the bases and set the exponents equal. Well, in this case, there's no additional algebra needed to solve, and so your answer is that x equals 8. And you can always take that 8 and plug it back in for the x in the original problem and make sure that your left and right sides are equal. So for part B, I have a base of 2 and a base of 4. I can rewrite.
Teacher's pardon interruption. We understand there's no sound on the presentation. We're working on it now, but nobody has sound. Thanks.
And make sure you click you're actually here whenever you hear those types of interruptions. So we have a base of 2 and a base of 4. 4 can be written as a base of 2. That is going to be 2 squared, and that's to the 2x minus 1 power. So I have 2 to the 5x equals 2 to the 2 times 2x minus 1 power. And you can go ahead and distribute that 2 at this step if you wanted to. I'm going to leave it separate, and I'm actually going to distribute once I rewrite this. So we can cross out the bases. So we have 5x equals, I'm going to distribute this 2 and get 4x minus 2. Subtract the 4x from both sides, and you get x is equal to negative 2. And again, you can check that by plugging it in. Our second example, this one, we actually have to change both bases because you have 8 to the negative x plus 6, 4 to the 4x plus 5. I can't write 8 as a base of 4, and I can't write 4 as a base of 8, but I can write both of these as a base of 2. So this is 2 to the 3rd, and then to the negative x plus 6 power, and 2 to the 2nd to the 4x plus 5 power. So then I'm going to cross out my bases and distribute my exponents. So this is 3 times negative x plus 6 is equal to 2 times 4x plus 5. We distribute. Get your x's on one side and your constant terms on the other side. You divide, and x is equal to 8 over 11. And again, you can plug that back in to make sure it works in the original problem. This process also works for inequalities, and there are none of these that are on the worksheet that you're going to be doing for exponentials, but I still wanted to make sure that you have some exposure to these types of questions. So I can rewrite both of these as base 5. Now the fraction is a little bit different. Let's see, 3 minus 2x. 625 is the same thing as 5 to the 4th power. Well, I need to have my base on the same level as everything else. So that's actually going to be a 5 to the negative 4 power. In order to flip that fraction, we need to put the negative with the exponent. So then I can cross out the bases, instead of an equal sign here, I am going to have an inequality. And then I want to go through and solve. So I have negative 2x is greater than negative 7. When we divide by the negative, remember you have to flip the direction the inequality opens. So we get x is less than 7 over 2. So if you pick any x value that's less than 7 halves, this is going to be a true statement. Next one, example 4. Again, I have another fraction here. We are still solving this equation. So I can write both of these as base 5. 1/5 is 5 to the negative 1. 25 is 5 squared. And then I can cross out the bases and distribute. So I have negative x plus 5 is equal to 6x plus 4. Get everything like terms on a single side. So I'm going to add the x to make that a 7x. Subtract the 4 to make that a 1. And we get x is equal to 1/7. This next one has two different equations in here, and this is introducing a concept we haven't used yet. We're going to be using some additional properties of exponents. So you still want to go into this with the goal of writing everything as the same base. And with number 1 here, we're going to write these all as base 3. Well, 243 is 3 to the 5th power. 27 is 3 to the 3rd power. 1/9, well, 9 is 3 to the 2nd power, and to flip it so that it's not in a fraction anymore, that's going to be 3 to the negative 2nd power. Now, if we look at the left-hand side of this equation, anytime you are multiplying two things that have the same base, because both of these have base 3, you add exponents. So if I were to add these exponents together, this is going to be 3 to the 5 times negative 2n minus n plus 3 times negative 3n. So when you multiply like bases, you add exponents. So you're going to add the 5 times negative 2n minus 2 to the 3 times negative 3n, and then I can cross out my bases and solve. So this is going to be negative 10n minus 10 minus 9n equals negative 2. So I have negative 19n is equal to, if I add the 10 to both sides, I get negative 8. Divide, and we get n is equal to 8 over 19. I think I missed something here. Oh, this 8 is not negative, this 8 is positive. So your final answer is going to be negative. Sorry about that. Number 2, this one is a little bit easier. You want to write everything as base 6. On the left-hand side, they are already base 6. So x plus 3x is going to be 4x. 216 is 6 to the 3rd power. So again, we cross out bases. We get 4x is equal to 3. Divide both sides by 4, and you get x is equal to 3/4. So there's your lesson on solving exponential equations using those properties of exponents. It'll give you a chance to practice using some of the properties that you might not otherwise be as comfortable with. So go back through, rewatch the video, pause it if you need to take any notes. Feel free to ask me any questions, and good luck with your work.